Hello students, today we're going to be looking at conditional statements. Please don't forget to take notes as you go and complete the survey that follows this video. So, what is a conditional statement? Well, a conditional statement is also known as an if-then statement. What we're going to be doing is focusing on those and their truth values, and we'll get into what those are in a moment. But first, a conditional statement is an if-then statement. What it does is it's made up of two parts. The first part is called the hypothesis, and sometimes we call that the P. This is the part that follows the if. So the if something, then something. The second part is the conclusion. We can indicate that as the quote-unquote Q. That follows the then piece. So what we can do is write it as P arrow Q, and what that represents is if P, then Q. That's usually how we say it. But sometimes you can also say P implies Q. So what we need to do is sometimes indicate if something is a true or false statement. And what that is called is a truth value. And again, that's telling us, is that statement true or false? Now, take note, just like with counterexamples and proofs, to show something is true, it has to be true that every time the hypothesis is true, the conclusion is also true. But to show that something is false, all I have to do is find the one counterexample, kind of like we were discussing in the last video. So, being able to identify the parts is very important. So here's an example with that. So if an animal is a robin, then the animal is a bird. So when we're identifying which piece is what, I want to know what the hypothesis and the conclusion are. The hypothesis always follows the if part. So in this one, hypothesis is an animal is a robin. The second part of this, which is following the then part of it, is the conclusion. So in this one, the conclusion is the animal is a bird. Why do we need to do this? Well, what we're going to be doing is not only identifying the conditional statement as the if-then statement, but we have other different types of statements that we need to know. So taking the hypothesis to conclusion and rearranging them is what we're going to be doing. So the first one here is the conditional. The conditional is our first if-then statement. What we use is the given hypothesis and conclusion if it's not already written as an if-then statement. So for an example, if the measure of angle A is equal to 15, then angle A is a cube. And this is something that we already know. So this is the if P, then Q statement. The converse takes that and exchanges the hypothesis and the conclusion and their placements. So using that previous example, we would switch it. So instead of saying if measure of angle A is equal to 15, it would be if the angle A is a cube, then the measure of angle A is equal to 15. And this is when we can observe our truth value, in this case, is false. How to read it, though, in terms of P's and Q's? Well, we would replace it. We would switch it. So if Q, then P. The inverse takes the original conditional statement and makes them both negative, meaning opposite. So if in this one it was talking the measure of angle A equaling to 15, now we're going to change it to measure of angle A not equaling 15. Then in that case, it would say that the measure for the angle is not a cube. So that's what I mean by negating the hypothesis and the conclusion. It's the opposite of what was already in there. So this would be if not P, then not Q. The contrapositive is the flip of that, or taking the converse and negating it. So it's the negative of both the hypothesis and the conclusion of the converse. So in our example here, it says if angle A is a cube, then the measure of angle A is equal to 15. What we're going to do is take that statement and negate it. So it's now going to be saying is if angle A is not a cube, then the measure of angle A is not 15. Now please make sure you note that it doesn't always necessarily have to be originally an equals and then a not equals. The original statement could say not something, which means the inverse would imply that there is something. So just keep that in mind. So writing it out in P's and Q's, this would be if not Q, then not P. This is just another graphic organizer, another way to look at things, how the conditional, converse, and those things look at it. I call the converse the flip, the contrapositive is the not, is the flip not, and the inverse is the not. So I'll go more in detail with that tomorrow. But we also have one other type, which is called a biconditional, and this is when we have ourselves a single true statement, where we have ourselves a conditional and its converse. If they're both true, then we can join everything and put an if and only if in the middle. So an example of that would be the conditional. If the sum of the two measure of angles is 180, then the two angles form a straight angle. And this is something that we know. Two things that are adding up to 180, it can form a straight angle. If we were to do the converse of that, if two angles form a straight angle, then the sum of the two measures is 180. So what we can see from this is we have ourselves two true statements. So what we're going to do is combine these two things together, get rid of that if in the beginning and the then in the middle, and switch it to the sum of the measures of two angles is 180 if and only if the two angles form a straight line. So this is the new piece here, if and only if the two angles form a straight line. If you have any questions, please bring them to class tomorrow or put them in the survey. Don't forget to do the survey that follows the video.